Hi, today we are going to do this problem. We have a research student investigating the maximum weight in Y grams of sugar that will dissolve in 100 grams of water at various temperature, blah blah. So we have x between 10 and 80. So x degrees Celsius, where x between 10 and 80. The student calculated the regression line and of y on x. Okay, remember the regression line is y on x. That means that you get the x value and then you calculate it for the y value. Okay, you don't do it the other way around. You don't take the y value and you calculate for the x value. You don't do that. You cannot do that, first of all. And second of all, it is only valid for between 10 and 80. If x is not between 10 and 80, it doesn't work. It's not a valid approximation. So the approximation of this equation, let me just write that down. This 151.2 plus 2.72x. This equation is valid only for plugging in x values and getting y values. It doesn't work the other way around. If you have a y value, you can't use this equation to find the x value, and it is only valid between 10 and 80. There we go. Right. Give an interpretation of the gradient of the regression line. So we have the regression line here. That is our gradient there. 2.72 is our gradient. So what is the interpretation of that? That is number A. So we want to know the interpretation of this gradient here. Remember, we can always write this as something like y is equal to mx plus c, like where y is the gradient and then c is the y-intercept. So one way to think about it, whenever we have something like this where we have y equals to a plus bx, in this case it looks like y is equal to a plus bx. A is the value when x is equal to 0. This is the value of, this is the A is the value of y when x is equal to 0. So this is actually the value of y when x equals 0. Right? So if you put x equals 0 in here, if you plug it in, then this disappears and it just becomes y is equal to A. A is the value when x is equal to 0. That is the definition of a y-intercept. It is the intercept of the y-axis when x is equal to 0, because the y-axis x is at x equals 0. But in the exam, you can't just write this. Of course, you have to kind of explain that this is the initial condition. For example, in this case, the value of that 151.2 is gonna be the grams of sugar, that amount of sugar, or like the mass of sugar in grams that is gonna dissolve at 0 degrees Celsius. Yeah. So at 0 degrees Celsius, 151.2 grams is gonna dissolve. You cannot write it like that. You can't just write, oh, it is the value of y when x equals 0. You can't write that because y and x are arbitrary variables. They're arbitrary numbers that we just, they're arbitrary letters that we just give them names to. So to actually interpret it, whenever it has to interpret it, we have to give them context of what the thing is, right? So for example, if we are measuring height versus shoe size, so we're gonna be plotting height versus shoe size. So let me just, for example, write it down for you. Height equals to, I don't know, 50 plus 20 shoe size, something like this. Let's say h equal to 50 plus 20s. Whenever you are asked of like what the values, what these y-intercept and gradient mean, you gotta give them context. So 50 is the height of a person with 0 shoe size, and okay, it doesn't really make sense, but just this is an example. Just come along with me. So when s equals 0, h is equal to 50. So the mean value 50 here. The meaning here is that 50 is the number where that is like the height of the person when their shoe size is 0. So you gotta give them in context of like what the value means in the context of the question, right? What the situation of the condition, the question is, what the condition, what the story is of the question. So in this question, we don't care about this. We're caring about the gradient. So what does the gradient mean? Now let's look back into our gradient formula. If we look back at our gradient formula, then you might recall that gradient is equal to y2 minus y1 over x2 minus x1, or in other words, it is the change in y divided by change in x. In other words, it is like change in y per unit of like x. So every time x changes in 1 unit, how much does y changes? That is what the gradient is. In other words, if x changes by 1 unit, 1 value, then y changes by this much gradient, right? To give you another example, like kind of understand it better, if we have something like, let's say, speed, for example. So speed is equal to distance over time, right? Let's say I go 50 kilometers in 2 hours. And that means that my speed is actually 50 kilometers per hour, right? So that means that every hour I am going 50 kilometers. Sorry, not 50, 25, sorry. 25, yeah, sorry. So every hour I'm going 25 kilometers. If I go up 1 more hour, I'm going to go up 25 more kilometers. If I go up 2 hours, I'm gonna go up 25 plus 25. So that is 50 kilometers, right? Every 1 hour, I'm going up 25 kilometers. So that means that plus 1 hour, meaning plus 25 kilometers. Every hour, I am moving 25 kilometers. Same interpretation here. Every time x goes up by 1, I am adding up 2.72 of the value to y here. In this case, every time x goes up by 1 degree, every time x increases by 1 degree, y is being increased by 2.72. And if you don't believe it, you can draw a graph and you can kind of figure it out. I mean, it's quite obvious because if you kind of do the calculation here, this is the original value. Let's say this is like x naught. Let's say y is equal to 15, sorry, 151.2 plus 2.72, let's say x naught. And then if we add 1 more, if we increase x by 1 more, let's say the new y new is equal to 151.2 plus 2.72 into x naught plus 1. Then if you subtract the 2, then you're gonna get, these are gonna cancel out, and you're gonna get just 2.72 because these are also gonna cancel out. In other words, if you increase x by 1, then you're increasing the value of y by 2.72. Like, this is just stupid calculation for showing you that no matter what value of x is, it doesn't matter if x is equal to 1, 2, 3, it doesn't matter if x is equal to 10 or 80 or 15 or 23 or I don't know, any value what x is. If you increase x by 1 unit, then that means that y increases by 2.72 units. So what does it mean? What is our final answer? I'm going to use all this. I think you got that. Our final answer is going to be that increasing by 1 value of x is going to increase the value of y by 2.72. But obviously, like I said, we cannot write that. The reason we can't write that is because we gotta increase the include the context of the question. And the context of the question is that this is in degrees Celsius, this is in gram, and this is like the amount of salt that is being dissolved in. So the answer is gonna be if if temperature increases, right? Yeah. Temperature, yep. If temperature decreases by 1 degree Celsius, I then that the amount of salt dissolved, sugar, sugar amount of sugar dissolved will be increased by 2.72, or like an extra 2.72 grams of sugar. There you go. Alright, let's go to number B. Use the regression line to estimate the maximum weight of sugar that will dissolve in 100 grams of water when the temperature is 90 degrees. So the little word that says 100 grams of water is kind of like a red herring to like put you off. I mean, it's not really, how do I call it? It's kind of like, yeah, to confuse you, to just put in numbers in. 100 grams doesn't matter, because in the original question up there it said 100 grams of water at various temperatures, so it doesn't matter how much we change a gram, it will still be the same equation, the same number of sugar, whatever. So we just need to care about 90 degrees Celsius, maximum weight that will dissolve in 90 degrees Celsius. So we just put 90 in here, except that we can't really do that. And number C asks us why we can't do that. So let's do number B first. Number B, at 90 degrees Celsius. Sorry, just put that with at 90 degrees Celsius, y is equal to 151.2 plus 272 into 90, which, if you calculate that with your calculator or whatever, I think I left a decimal place here. Yeah, you will get about 396. So that means that the answer is 396 grams of sugar. There we go. Okay. Now number C asks us, comment on the reliability of your estimate, giving the reason for your answer. So it is unreliable because it is outside the range. So number C, unreliable, because I think I'm gonna put it this way. Yeah, whatever. Because 90 degrees is outside the range of 1080. There you go. Great. Using the regression line of y on x in the following summary statuses, so we have some more summary statuses, show that the product moment correlation coefficient, so PPMCC, of this data is equal to 0.988 to 3 decimal places, which is 3. So what I'm gonna do is, I'm gonna call a new page, but you got this, right? I'm gonna erase the board. Alright, we have some more summary statuses. We just use that. Summation of y is 3119. Summation of y squared is 851093. and then summation of x squared is 24500. 24500, and it's equal to 12. Alright, these are our summary statistics. Nice. So what does it want us to calculate? PPMCC. So let's recall the formula for product moment correlation coefficient. Remember, Pearson. So it is invented by Pearson, of course. The guy named Pearson, who's the founder of Pearson AXL, invented this stupid ass formula, which is why he named it after himself. And he also named Pearson AXL after himself. Like, that's his name. He called Pearson his own name. Wait, his name is Pearson, and he also called this formula his own name. So his Pearson. Product moment correlation coefficient, that is equal to, let's say, PPMCC. In short, we call it R. Right, so we just need to calculate what R is. And the formula for R is actually equal to 1, it is in your formula sheet. Just look at your formula sheet. I don't remember by heart. Jesus. Let me just look for it real quick. Just give me a second. I forgot. It's been so long since I did this. Oh, SXY, SXX, SYY. There you go. R is equal to S. I don't know if you can see it clearly, but SXY divided by square root of SXX SYY. That is the formula for the product moment, Pearson product moment correlation coefficient. Yeah. Alright, so we're gonna use that. Now, do we know SXY? We do not know SXY. Do we know SXX? No, we don't. Do we know SYY? No, we do not. So how do we find SXX, SYY, and then SXY? Again, they are in your formula sheet. So look at your formula sheet, and then let's just work that down. So let's start from SXY. That is equal to Jesus, it's not coming to my head. What is SXY? Summation of summation of x squared minus summation of x the whole square divided by n. Yeah, so you do need to remember this. Summation of, no, it's not. What? A summation of xy minus summation of x summation of y divided by n. Yeah, summation of xy. Except that we don't have summation of xy. So we'll, okay, this question is a bit hard because this information is embedded in here. It's like hidden inside here. We need summation of xy, but we don't have summation of xy, and so we have to kind of find summation of xy from the regression line equation, and that is a bit hard, but yeah, let me just write down the formula here first. So Sxy is equal to summation of xy minus summation of x summation of y all divided by n. That is our formula. Yeah. The problem is that, oops, there we go. I think you can see that. Okay. Oh my god, it's falling. Wait. Let me just get a good stand on here. There we go. Right. So anyways, yeah. Summation of xy is, we don't know that. But we'll get to that later. We'll try to find what that is later. But yeah, here's my marker. We can, from here, we can also write down the formula of sx and s for y. So sx is equal to, we just substitute x with y here. Sorry, y with x. Here y, here y. We substitute it with x. So we get summation of x times x, that is summation of x squared, which is what we have, minus this is summation of x, the whole square. We don't have that. We'll find that out later. Divided by n, and then syy is equal to summation of y squared. We just substitute this with y minus summation of y, the whole square divided by n. Right, these are summations for me, by the way. My handwriting is bad. So let's look at the information that we have so far. We have summation of y squared. So we can already calculate summation syy here. We can already calculate this. Sxx, we can't, we have a squared here, summation of a squared, but we don't have summation of x. We don't have summation of x, so we can't calculate that yet. Sxy, we don't have summation xy, we don't have summation x. Yeah, right. So let's look at this formula here. Let's look at what a and b are. If I remember correctly, then a would be the formulas for, let's start with b. The formula for b, which is the gradient, the formula for b would be equal to sxy divided by sxx. That is the formula for b. From what I remember, I might be wrong. B is equal to sxy by sxx, and then a is equal to y minus b x bar. Yeah. Okay. This is b. So we just find sxy, sxy, sxx, and then plug it into here. So that means that we can actually find sxy. Let's just put it aside for a second. Then we know that a is equal to, if you rearrange it, we get y bar minus b x bar, which is just y over n. So summation of y over n minus summation of b. So b minus summation of x over n. That's okay. This is a bit hard. So I'm gonna switch pen. I'm going to start doing some algebra manipulation and stuff. Let's start with this. So we have 2.72 is equal to sxy divided by sxx. We know this. So that means that sxy is equal to 2.72 sxx. So when we see an sxy, we can kind of substitute it with 2.72 sxx. So if we just find xx, we don't need to find sxy. Like, look at this. We don't really need to find sxy using that formula. If we find sxx, oh my god, I lost my cap. But yeah, if you can find sxx, then you don't need to find sxy anymore, because sxy has summation xy here, which we don't know. We don't know what summation xy is. And because we don't know what summation xy is, we cannot find sxy here. And so we can't really find sxy. That means that we can use this formula here to find sxy using sxx. Okay, and how we got sxx is by manipulating this. Just to recap, b is equal to sxy by sxx. This is the formula inside your formula sheet, and then we plug that in. B is 2.72. Plug it in, rearrange, you get that. All right. So far so good. Let's look at a here. Just circle this. Where do my tabs that keep disappearing? Can't really use that. Oh, here it is. Let's put this in a box to highlight it, and then we'll move on to this equation here, which is 151.2 plus equals to y bar, which is summation of y divided by n, which is 12, but I'm gonna write n, minus b is 2.72, and then x bar is summation of x divided by n. Here, does this make sense to you? Because y bar is the average of y. The average of y is the summation of all y. You add every y together divided by n. Or you can just write memorize the formula that says y bar is equal to summation of y over n. Same with x bar. X bar means that it is the average of all x. It is the mean of x. Mean of x meaning that you add up all the x together and then you divide it with n, which is that. Or just remember the formula. Right. That means that we can get a relationship between x and y, summation of x. Oh, no, we already got it. We got summation of x here. Nice. So I'm just gonna plug in everything, okay? I'm just gonna plug in everything. Let me just also box this. There we go. So we plug in everything. We should, okay, so because we know summation of y here, we already know what the summation of y is given in the question. Because we know that, then we can plug summation of y in here. We know what n is equal to 12. We can plug 12 in here, 12 in here. That just leaves the summation of x, and then we can solve for summation of x, and then we will get summation of x finally. So we can get summation of x from here. Once we get summation of x from here, we can plug it into here. We get sxx. So we put sxx in here, and then from sxx we get sxy. So we put sxy in here. All we have left is syy. Syy we can calculate using summation y squared and summation y the whole square. If you did not catch that, just rewind and go back a few seconds. Listen a bit back. But to summarize everything again, this is what we're trying to find out. This is the formula that we need to use to find r. R is Pearson product moment correlation coefficient, and that's the formula. Pearson invented it. Sxy formula here, Sx formula here, Syy formula here. Sxy you need summation of xy here. Summation of xy, we don't know that. We cannot know that. It is not in the question. There is no information about summation of xy. So we gotta improvise. How do we improvise? We look at the regression line formula. From the regression line formula, we can find a and b. So not find, we can tell a and b. This is a, this is b. Using the formulas for a and b, we have b here, which is sxy over sxx, and then we have a. A formula is y bar minus b times x bar. From this, we can create a relationship between sxy and sxx using b. So in this case, this is going to be 2.72, which is b, equals to sxy over sxx, and then we get a relationship between sxy and sxx. That means we do not need to use this formula to find sxy. We just need to plug sxx into here, find sxx, plug sxx into here, and from there we can find sxy. So in other words, just find sxx. We don't need to find sxy, just find sxx, and from sxx you can then find sxy. So plug this in here. That is what I mean. Finally, syy is simple. To find syy, we need to use this formula. Put it in there. So how do we find sxx? That is a big question here. So to find sxx, we are going to use this here. A is 151.2, that is y bar minus b times x bar. Y bar is equal to summation of y over n. X bar is equal to summation of x over n. Plug it in here. Y bar, summation of y, we already know that. Summation of x, that is what we're trying to find, and we already know that. So from this equation, we get summation of x. So we take the summation of x, we plug it in here. Summation of x squared, we already know that. Summation of x, we get it from here, plug it in here, and we already know that we get sxx. Alright, so let's go back in reverse. Starting from the end, go back to the beginning. Let's start. So we have this equation here. We got it from here. From this equation, we have summation of y, plug it in here. We have n, plug it in here. We have n, plug it in here. We get summation of x. Summation of x, we plug it in here. Summation of x squared, we plug it in here. N, we plug it in here. We get sxx. Sxx, we plug it in here. And then we get sxy, alright? So we have sxx, sxy. Syy, we can just find it from here. Y squared, plug it in here. Y, where's y? Y, we'll plug it in here, and then n equal to 12, plug it in here. We now have all three, sxx, sxy, and then syy. So we can plug all of these back in here, like that. So let's calculate that. Starting down here, right? 1512. Oh, I haven't erased this. Just a second. Where were we? We were doing the calculation of 151.2 is equal to summation of y for n. So let's, what number is this? Number D. Number D. 151.2 is equal to summation of y, which is 3119 divided by 12 minus b into, which is 2.72 into summation x over 12. Yeah, summation x over 12. I don't know if I draw my calculator, but this means that we finally have summation x here. So summation x is equal to, plug in your calculator, get summation x. No, I did not bring my calculator. Oh no, I did. Yes. So 151.2 minus 3119 for 12, all divided by no, sorry, this goes here. So 319 over 12 minus 151.2, all divided by 2.72 multiplied by 12, get 479.63. 479.63. This is the summation of x. Nice. Now that we get the summation of x, we can now plug it in into this equation here to find Sxx, right? Yeah, we can find Sxx from there. So that means that Sxx is equal to summation of x squared, which is summation of x squared is equal to 24500 divided by 12 minus summation of x the whole square, right? Yeah, summation of x the whole square divided by n. So summation of x the whole square is 479.63 the whole square divided by 12. Sorry, there's no divided by 12 here, my bad. 500. There we go. Yep. Okay. So this is our formula for 6x. Taking that, we get Sxx is equal to just put it in my calculator. Five three two 9.40. 5329.40. 5329.40. Right, and now we can use this to find Syy. So Sy, sorry, not S. I mean, we can find Syy too, but yeah, let's find Sxy first. Sxy is equal to b times Sxx. If you remember from the last slide, let me just show it to you real quick. There, 2.72 Sxx. 2.72 into 5329.40, and then we get wait, I fucked up. 3119 over 12 minus 151.2 all divided by 2.72 multiply 12, 24500 minus answer squared divided by 12, then multiply 2.72. 14495.97. 14495.97. There we go. By the way, I'm using the answer key on my calculator. I'm just clicking answer. So here to here, I clicked the answer key, like right here, and then here to here again, I clicked the answer key, so that the answers get carried over, and then you're not really approximating it. There's no decimal places that you're cutting off. If you just type in 5392.40, you're cutting off the decimal place here, and all this goes into error, and then in your final answer you're gonna have some bit of error. Right, and then Syy, forgot about that. Syy is equal to summation y squared, which is 851093. 851093 minus summation y, which is 3119 squared divided by 12, and then we get Syy. Syy is equal to 851093 minus 3119 squared divided by 12. 40412.92. 40412.92. 40412.92. Right. Then we can put everything back into our one big beautiful formula, which is Pearson product moment correlation coefficient, which is R, is equal to Sxy, which is 14495.97 divided by square root of a 6/8, which is 5329.40 minus, sorry, not minus, multiply SYY, which is times 40412.92. There we go. Put it in your calculator. You will get your final answer. So we have 0.98775. 98775. My ink not working. And then what is the question asking? Show that it is 0.988. So this is 0.988 to 3 decimal places. Then it is shown. There you go. Nice. So the research student supervisor plotted the original data on the scatter diagram as shown on page 23. So on page 23 we see a scatter diagram there. That's a nice diagram. They discuss the sustainability of a linear regression to describe the relationship between x and y. So you can see the graph there, and do you think, so basically what the question is asking is, do you think this diagram here, I'm going to show it up on screen here, do you think that diagram there is suitable, like sustainable or suitable to use a linear regression model? Is it suitable to use a linear regression model to describe the relationship between x and y? So basically to describe this graph. So look at the scatter diagram graph here. Is it suitable to use a linear regression model to describe that? Right? So let me see here. If you look at the graph, you can, if you kind of think about drawing a best fit line or drawing a curve, even if you even try to draw a curve, the best you can do is a line. So that means that yes, it is suitable because points are pretty close to the points. I mean, the point are pretty close to the regression line, and you kind of have to say that this is a strong positive correlation because PMCC is very close to 1, right? So that means that P, writing because green is better. P and CC is very close to 1. That means that it is a very strong positive correlation. And then the points are close to a straight line, linear, yeah. Points are close to a linear. This is a linear straight line. A straight line. Therefore, it is suitable. And there you have it. So if that isn't clear, you can ask me more questions. But yeah, that's about it. All right. See ya.